Page 49. Module 3.2 Profit Maximization. Rationale: the profit maximization of a perfect competition helps to derive the supply curve of the firm. The supply curve of a firm denotes the level of output produced at a different value of the market price. Key concepts: profit, loss, profit maximization.
3.2.1 Profit maximization of a perfectly competitive firm. We assume that irrespective of the type of market a firm operates in, its primary concern is to produce and sell that much output which maximizes its profit. The total revenue from any given output subtracted by the total cost of production of that output is known as profit from the sale of that given level of output. Profit is denoted by the symbol pi and is calculated as pi is equal to TR minus TC. Since TR and TC are both functions of the output, therefore pi also becomes a function of the output. If we plot the graph of this profit function by placing quantity on the x-axis and profit on the y-axis, then we get the profit curve.
Page 52.
Figure 3.5a Profit curve. Here we have a graph with two axes. The x-axis represents quantity. The y-axis represents profit in rupees. The x-axis has been divided into 5 equal parts. The y-axis has been divided into 6 parts which are at an interval of 5 and extend from minus 15 to plus 15. There is an upward sloping curve here which originates from minus 10. It intersects the x-axis at point 2 and this curve is at its maximum point at point C, which represents 4 units of quantity and 10 rupees of profit. After this, the curve starts going in the downward direction and intersects the x-axis at point 5. A firm's objective is to choose that level of output which maximizes its profits. At any level of output, the profit is calculated as TR minus TC, which could either be positive, negative, or 0. Negative profit is known as loss. Suppose a firm decides to increase the output produced and sold by 1 extra unit. Then the total revenue would change and become the marginal revenue as delta TR is equal to MR, and the total cost would change to become the marginal cost as delta TR is equal to MR for that extra unit of output. A question of importance is that how much should a firm produce to earn profits? If at any unit of production revenue is more than the cost, then profit will emerge. On the other hand, if production of a unit adds more to the cost than to the revenue, then in such a case, production and selling of that unit will decrease the profit. Therefore, the firm will earn profits at the output level where revenue exceeds the cost. For this reason, we can say that
1.
MR is more than MC. Then, profit increases when output is increased by 1 unit.
2.
MR is less than MC. Then, profit decreases when output is increased by 1 unit. The next important thing is to identify the level of output where profits can be maximized by a firm. It is profitable for the firm to produce the output at which marginal revenue equals the marginal cost. However, it is not a sufficient condition for profit maximization. In figure 3.5b, output Q1 at point A will earn minimum profit, as thereafter profit can be increased with an increasing quantity of output. Point A onwards, MC curve starts falling and is below MR curve. Profit will be maximized at point B with an output of Q2 since MC curve cuts the MR curve from below. Output beyond Q2 is not profitable because then marginal cost begins to exceed the marginal revenue. In figure 3.5a, MC curve is above the MR curve beyond the output level Q2. In such a case, profits can be retained by reducing the output produced and sold towards point B, that is output level Q2. Page 53.
Figure 3.5b. Profit maximization condition of a perfectly competitive firm. We have before us a graph where on the x-axis we have quantity represented by points Q1, Q2. The y-axis represents revenue in rupees and is marked by point capital P. A horizontal line extending from point P on the y-axis represents MR equals AR equals P. This is parallel to the x-axis and there is a U-shaped curve MC which intersects it at point A, which is represented by Q1P, and at point B, which is represented by Q2P. Therefore, two conditions that must be satisfied for a firm to maximize its profits are
1.
MC equals MR.
2.
MC curve must cut MR curve from below. We assume that the perfectly competitive firm makes a decision to maximize its profits. Such a profit maximizing condition can be studied in two ways.
1.
By analyzing the TR and TC curves, and
2.
by analyzing the MR and MC curves. We have earlier derived the profit maximizing output by studying the MR and MC curves. Let us now consider TR and TC curves, which have been drawn in figure 3.6a. A firm incurs losses when TC is more than the TR, and it incurs positive profits when TR is greater than TC. On analyzing figure 3.6a, TR curve is above TC curve from point A to point B, that is, from output level Q1 to Q3. These point A and B are called break-even points, as on these points TR equals TC. We analyze the vertical gap between the TR and TC while calculating profits. Further, the output level at which the vertical gap is maximum is considered to earn maximum profits. On output level Q2, the vertical gap is found to be maximum. This lies in the middle of the points A and B. TC has fallen minimum for this output and has begun to rise beyond this output level. Thus, we may summarize for profit maximization condition through TR and TC curves as
1.
TR should be greater than TC.
2.
Vertical gap between TR and TC should be maximum. Page 54.
Figure 3.6 A. Total revenue and cost approach. We will study this figure along with the next figure, which is figure 3.6 B. Marginal revenue and cost approach. In figure 3.6a, we have a graph with two axes. The x-axis represents quantity, the y-axis represents TR or TC in rupees. The x-axis has been divided into 14 equal parts. The y-axis has been divided into 6 parts, which stand at an interval of 10 each. In this graph, we have an upward sloping line which originates from the origin. This is TR. There is another line which is in the shape of an inverted S. This line originates between the points 0 and 10 on the y-axis, and it intersects the line TR at the points A and B. This line is TC. If we study the point E on TR and F on TC, the distance between both these points represents maximum profit. Now, let's study the next graph, which is connected to the graph we studied just now. In this graph, which is figure 3.6b, we have quantity on x-axis and MR or MC in rupees on the y-axis. The x-axis has been divided into 14 equal parts. The y-axis has been divided into 7 parts, which are at an interval of 5 each. There is a line here which originates from the point 10 on the y-axis and is parallel to the x-axis. This line represents MR. There is also a curve here which is in the shape of U. This is the MC curve and it intersects the line MR at the points G and H.
When we study the graphs figure 3.6a, total revenue and cost approach, together with figure 3.6b, marginal revenue and cost approach, we will find that a perpendicular dotted line connects point A on the graph TR to the x-axis of the graph 3.6b at point Q1. This intersects MC and MR at point G. A line, perpendicular and dotted, also connects point E on the first graph to point Q2 on the x-axis, intersecting MC and MR at point H in the second graph. Point B on the first graph is connected to point Q3 on the y-axis of the second graph through a dotted line again. This too intersects MC and MR. You will realize that the marginal revenue and cost are derived from the total revenue and cost.
Follow figures 3.6a and 3.6b simultaneously. At the output level Q1 and Q3, MC is not equal to MR. However, TR and TC are equal to each other. At the output level Q1, MC is at its minimum, and at the output level Q3, MC is greater than MR. Thus, the output levels Q1 and Q3 are not profit maximizing outputs, as they do not fulfill the required conditions. But at the output level Q3, MR is equal to MC, and MC curve cuts MR curve from below. Further, at this output level, the vertical gap between TR and TC is maximum. Hence, Q2 is the output that generates maximum profit to a firm. 3.2.2 Equilibrium of a perfectly competitive firm in the short run. In a perfectly competitive market, a short run can be understood as a time period in which the firms are
1.
Fixed in number, as it is difficult for them to frequently enter and exit from the market.
2.
Firms have the option to shut down.
Page 55.
To calculate the supernormal profits, loss, normal profit and shutdown condition of the firm in the short run, we draw MC, AC, AVC and price line together. Note that MR is equal to AR is equal to price. Assuming that the price is given to the firm by the market, which varies in the short run, we shall consider the following sub-cases.
1.
Market price is more than minimum of short-run average cost, or SAC. Refer to figure 3.7. Profits are maximized at the output level Q, where MC is equal to MR, and MC cuts MR from below at point M. Area of the rectangle OPMQ gives us the total revenue at Q, At the output level Q, we draw a point B on the AC curve, corresponding to the output level Q, and so AC is given by the height of the line segment BQ. If we now drop a perpendicular from point B on the y-axis, then that perpendicular intersects y-axis at point D. Area of the rectangle ODBQ gives us TC at the output level Q. Note that area ODBQ is smaller than area OPMQ, implying that the firm is not just able to cover all its cost out of its revenue, but also earns some positive profit in the short run. The profit of the firm is given by the area OPMQ minus the area ODBQ. It becomes equal to area DPMB. Such profits are known as supernormal profits, earned by a perfectly competitive firm in the short run. Figure 3.7. Market price more than minimum of average cost. Here we have a graph with two axes. The x-axis represents output. The y-axis represents cost in rupees. There is a straight line here which originates from the point P on the y-axis. This line is parallel to the x-axis and represents MR is equal to AR is equal to P. There is a curve here in the shape of U. This is the MC curve and it intersects the MR is equal to AR is equal to P line at the point M. There is another curve here in the shape of U. This is the AC curve. Now, if we drop a perpendicular from the point M towards the x-axis, we reach the point Q on the x-axis. Again, if we draw a straight line from the y-axis from the point D, this will intersect the line MQ at the point B. 2.
Market price equals a minimum of short-run average cost, that is SAC. Refer to figure 3.8. The AC curve is tangent to the price line at point M, which is the profit maximization point. As discussed earlier, the area OPMQ is the TR, and since AC is denoted by line segment MQ now, thus the area of OPMQ is also the TC. Hence, TR equals TC. And so the firm is earning zero economic profits, and it is just able to cover its total cost. This price, which is equal to the minimum SAC, is known as the break-even price, as the firm just breaks even without any economic loss or profit. This is a condition of normal profits to the firm.
Page 56.
Figure 3.8. Market price equals minimum of average cost. We have before us a graph with two axes. The x-axis represents output and the y-axis represents cost in rupees. On the y-axis from point P, we have a line which is parallel to the x-axis. This represents MR equals AR equals small p. The MC curve is a U-shaped curve and it intersects the line MR equals AR equals small p at point M. The other U-shaped curve, AC, also intersects MC as well as MR equals AR equals small p at point M. There is also a dotted line which connects point M to point Q on the x-axis. OQ represents output.
3. Market price is less than minimum short-run average cost or SAC. Refer to figure 3.9. Note that point B is the minimum point on the AC curve and is corresponding to the output level Q. Hence, the area ODBQ represents the total cost of a firm. If the price given to the firm by the market happens to be less than the minimum SAC, then the firm's total revenue is given by the area OPMQ, which is less than the area ODBQ. Such a firm is making economic loss, represented by the area PDBM, derived by subtracting area OPMQ from area ODBQ in the short run. Figure 3.9. Market price is less than minimum of average cost. Here we have a graph with two axes. The x-axis represents output. The y-axis represents cost in rupees. There is a straight line here originating from the point P on the y-axis. This line is parallel to the x-axis and represents MR is equal to AR is equal to P. There is a curve here in the shape of U. This is the MC curve and it intersects the line MR is equal to AR is equal to P at the point M. There is another curve here which is also in the shape of U. This is the AC curve. The AC curve and MC curve intersect each other. Now, from the point D on the y-axis, if we draw a straight line, it reaches the AC curve at point B. From the point B, if we draw a perpendicular towards the x-axis, this perpendicular line will intersect the line MR is equal to AR is equal to P at the point M, and also it will end at the point Q on the x-axis.
4. Market price equals minimum average variable cost, AVC. Even when the firms incur losses, they continue production as their variable cost and a part of the fixed cost is met by the revenue earned. Now the question is that up to what level can the firm continue producing even on bearing losses?
Page 57.
To determine an answer for this, we take the help of an average variable cost, AVC curve. Refer to figure 3.10. The AVC curve is drawn below the AC curve. When the average variable cost curve becomes tangent to the price line, then in such a case, the firm becomes indifferent between producing its profit, maximizing output, and producing nothing, as in both of these cases, the firm has to bear the loss of the total fixed cost. The firm now has the revenue just enough to meet the total variable cost. The area OPMQ represents the total revenue and also the total variable cost. Point M is the shutdown point, and the price equal to minimum AVC is known as the shutdown price. Any fall in the price line below the minimum AVC will make a firm shut down its operation in the short run. As in that case, revenue of a firm will not be able to cover even its variable cost of operation. Figure 3.10. Market price equals minimum of AVC. We have before us a graph with two axes. The x-axis represents output and the y-axis represents cost in rupees. From point P on the y-axis, there is a line parallel to the x-axis. It represents MR equals AR equals P. On this axis is point M. Please note that on this line at point M, we have two slopes intersecting. One is the U-shaped curve MC and the second is the U-shaped curve AVC. Above these two is the AC curve, which is also U-shaped. There is a dotted line which connects point D on the y-axis to point B on the AC curve. This is parallel to the x-axis. Now from point B, when we draw a perpendicular line which ends at Q on the x-axis, it intersects through point M. BQ is the entire dotted line.
Table 3.2 summarizes the discussion on the conditions of profit and loss of a perfectly competitive firm at a different level of market prices. Table 3.2 Profit and loss conditions of a perfectly competitive firm. Here we have a table with 2 columns and 5 rows. The first column represents market price or small p. The second column represents profit or loss. Now, if the price is more than minimum of SAC, then there will be supernormal profit. If the price is equal to minimum of SAC, there will be normal profit. If the price is less than minimum of SAC, there will be loss. If the price is equal to minimum of AVC, there will be loss, which will be equal to total fixed cost. This will be the point of shutdown. If the price is less than minimum of AVC, there will be loss, which will be more than total fixed cost. This will also lead to shutdown of the firm.
3.2.3 Short-run supply curve of a perfectly competitive firm. Supply curve of a firm shows the level of profit maximizing output corresponding to each market price. In the short run, a firm decides to produce output even while making losses, provided that the losses are not more than the total of the fixed cost of production.
Page 58.
So we have learnt that
1.
a firm will not be producing anything if the price of its product is less than the minimum of AVC.
2.
If the price is equal to the minimum of AVC, then the firm is indifferent between producing nothing or producing that level of output where MC equals MR and MC curve cuts MR curve from below. What it means is that for any price level above the minimum of AVC, the corresponding quantity determines the supply curve of a perfectly competitive firm. Since there is no production by a firm when the price falls below the minimum of AVC, there will be a supply of 0 units. As you know, the quantity supplied by a firm is determined by its market price, that is AR. In case of a perfectly competitive firm, market price, within brackets, AR equals price equals MR, close brackets, of a quantity equals the marginal cost of producing it, that is, MR equals MC. Thus, the supply curve derived for such a firm is the same as its marginal cost curve, but only above the minimum of average variable cost. Figure 3.11a and 3.11b derive the supply curve of a perfectly competitive firm. At point A in figure 3.11a, MC curve cuts the price line P1 and also the AVC curve at its minimum point. This is also the shutdown point, and so any production will not take place below this point. The quantity supplied is Q1 at point A. As prices increase from P2 to P3 to P4, the quantity supplied also increases from Q2 to Q3 to Q4. Figure 3.12b provides the supply curve for a firm. It indicates the quantity that a firm will produce and sell at a corresponding market price. Follow figure 3.11a and 3.11b simultaneously to note that the shape of the supply curve is the same as that of a marginal cost curve for all the prices above the minimum average variable cost curve. Figure 3.11a deriving supply curve of a perfectly competitive firm. We have before us a graph with two axes. The x-axis represents quantity. At equal intervals are plotted the points Q1, Q2, Q3 and Q4 on the x-axis. The y-axis represents price in rupees. The points P1, P2, P3 and P4 are plotted equidistantly on the y-axis. There are two U-shaped curves in this graph. The dotted line represents MC and the thicker line represents AVC. MC and AVC intersect at point A, which is Q1, P1. Point B on the MC is represented by Q2, P2. Point C on MC is represented by Q3, P3. And point D on MC is represented by Q4, P4. Figure 3.11b, supply curve of a perfectly competitive firm. We have before us a graph with two axes. The x-axis represents quantity. The points Q1, Q2, Q3, Q4 are marked on the x-axis equidistantly. On the y-axis, we have price in rupees, which is represented by points P1, P2, P3 and P4, which are at equidistant intervals from each other. When we join the points of intersection between Q1, P1, Q2, P2, Q3, P3 and Q4, P4, we get the supply curve S. This supply curve can be derived from the MC and AVC curves in the previous graph.
3.2.4 Equilibrium of a perfectly competitive firm in the long run. The long run for a perfectly competitive firm is characterized by a time period of adjustment in which it can
1.
Change the level of fixed input.
2.
Enter or exit the market. New firms want to enter this market if and only if the existing firms are making supernormal profits in the short run. Supernormal profits of existing firms attract entry of new firms. Old existing firms want to exit this market if and only if they are making losses even after they have adjusted their fixed inputs, for example, physical capital stock, to minimize their cost of production. If the price is above the minimum LRAC, then the existing firms will be earning supernormal profits, and this will attract new firms to enter into the market. This will add to the existing number of firms and hence the production will also increase at the ongoing price. As a result, there will be an excess supply which will thus pull the price down to minimum LRAC. When the price becomes equal to the minimum LRAC, that is a situation of normal profit, then the entry of new firms will also stop. Suppose the price for some reason falls below the minimum LRAC, then the existing firms will make losses in the long run and some of them will choose to exit the market, thereby decreasing the supply at that ongoing price. A situation of excess demand will cause a rise in price to the level of minimum LRAC, which is again a situation of normal profit. Firms will now stop exiting the market. Hence, in the long run, price in the perfectly competitive market will be always equal to the minimum LRAC, owing to free entry or exit of the firms. Therefore, the equilibrium of a perfectly competitive firm in the long run will be attained at the level of output where P is equal to MR is equal to LRMC is equal to LRAC. A perfectly competitive firm always earns normal profits in the long run.
Page 60.
Figure 3.12. Long run equilibrium of perfectly competitive firm. Here we have a graph with two axes. The x-axis represents output. The y-axis represents cost in rupees. There is a curve here which represents LRMC. There's another curve in the shape of U like the first one, and it represents LRAC. They both intersect at point M. The point M represents P1 level of cost and Q1 level of output.
Test your understanding.
1.
A tennis ball company faces costs of production as marked in the table given here. This table has 7 columns and 7 rows. The columns represent Q, TFC, TVC, TC, AVC, AC, and MC. The first 3 columns have values indicated in them, and you have to estimate the corresponding values of TC, AVC, AC, and MC. Row 1, when Q equals 0, TFC is 100 and TVC equals 0. Please answer and fill in the blanks for the remaining columns. Row 2, when Q is 1, TFC equals 100 and TVC is 50. Please fill in the blanks for the remaining columns. Row 3, when Q equals 2, TFC equals 100. TVC is 70. Please fill in the blanks for the remaining columns. Row 4, when quantity equals 3, TFC equals 100. TVC is 90. Please fill in the blanks for the remaining columns. Row 5, when Q equals 4, TFC is 100 and TVC is 140. Please fill in the blanks for the remaining columns. Row 6, Q equals 5, TFC equals 100, TVC is 200. Please fill in the blanks for the remaining columns. Row 7, Q equals 6, TFC is 100 and TVC is 360. Please fill in the blanks for the remaining columns. As requested above, please calculate TC, AVC, AC and MC at each level of production.
B.
The price of one tennis ball is Rs 50. Dealing in a perfectly competitive market, the company owner decides to shut down the company. Do you think the company's owner made a wise decision? Explain.
2.
Mr. Das has been selling water bottles at a market price of Rs 50 per bottle. He could sell 40 bottles in a month, thereby having a monthly total revenue of Rs 2000.
A.
He bears a cost of Rs 30 per bottle. What is his total cost?
B.
What is the profit, that is pi, that he is able to earn? Hint: TR minus TC equals pi.
C.
What is the average revenue earned by Mr. Das?
D.
Mr. Das plans to donate Rs 400 every month for charity, but he does not wish to reduce the amount of his profit earned. What do you suggest Mr. Das should do so that he can donate Rs 400 without reducing his profit?
Page 61. E.
In order to increase his revenue, Mr. Das started selling water bottles at Rs 60 per bottle, ignoring the market price of Rs 50 per bottle. How many units will he be able to sell so that he earns a revenue of Rs 3000? Hint: Mr. Das is dealing in a perfectly competitive market.
3.
What are the 2 important conditions of profit maximization in a perfectly competitive market?